Welcome to the Crazy Hat Chemist. So here we go today, the 10th video on bonding. Today we're going to be talking about alloys of metals. So let's get going. Bam! So, alloys of metals. An alloy is a combination of two or more metals or non-metals. Okay? It's accomplished through melting. And alloys have unique characteristics such as strength, huge strength, maybe weak strength as the case may be, resistance to corrosion, color potentially, hardness, and specific applications. Those are just a few of the unique characteristics of alloys. So we spend a lot of time making alloys. Okay, so here is in the upper left-hand corner a pure metal. So you should see all those red dots representing a particular element, bam, 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 in a particular order, like all gold or all copper, doesn't really matter. Okay, the one in the upper right-hand corner is a substituted alloy. And a substituted alloy is when you replace one atom for another. So you should see that I've removed a red one and replaced it with a blue one. An example of this is either bronze or brass. Bronze or brass is a substituted alloy. Okay, then the next one here on the lower left-hand corner is an interstitial alloy. An interstitial alloy is inserting one atom between another. So I have not removed any of the atoms, but I've just replaced an atom and put one in between them, kind of like in the open spaces in between them. So a steel is an example of this, and this is with iron and carbon. The lower right-hand corner is a substituted interstitial alloy. And a substituted interstitial alloy does both of these combined together. That is, removing atoms from certain locations, replacing them, and also placing atoms in between atoms. There are various different forms of steel that have this characteristics, and that is iron and carbon is that interstitial alloy alone, but when you insert nickel and chromium in between the spaces, then we have an interstitial substituted alloy. All right, so here are some examples of some alloys. Okay, brass is an example of an alloy. It's an example of copper and zinc combined together, melted together, and most of those, that's why they call them brass instruments. Okay, right over here we have the gold metal, we have the silver metal, and then we have the bronze metal. And the bronze metal is copper and tin. Okay, there used to be a Bronze Age, just like the Iron Age. Think about that. Then right over here, we have gold. We have at the top of this pyramid. At the lower left-hand corner, we have silver. In the lower right-hand corner, we have copper. Now, if we combine gold and silver or gold and copper in various different forms, or gold, copper, and silver, then we will have different forms of gold. And that's why you get different hues of gold. So, and each of those different kinds of gold have different colors. Okay, there's actually this greenish gold, which is like super cool. Okay, check that one out. Okay, samurai swords are an incredible metallurgy process. And the samurai sword is two different forms of carbon. It's a high carbon steel and a low carbon steel sandwiched together. And the ancient samurai makers of these swords came up with this process, which was much stronger than any other sword. And when it was cooled down, then it caused the bend in the sword blade. And that was very easy to, well, use as a weapon then. Okay, these knives, which are the equivalent to a samurai sword, except we use it to cut food. And these are VG10 stainless steel. This is a very hard and very supple yet stainless steel. Okay, it has iron, carbon, molybdenum, chromium, vanadium, and cobalt to make this VG10 steel. It's exceedingly hard, exceedingly strong, and it will retain its cutting edge for a very long time. That's why these particular knives are like thin as razors, but yet you can cut a tomato or even a sheet of paper or even a silk handkerchief. Beautiful. I am the Crazy Hat Chemist, and that's why I am wearing my Irish hat today. So, I hope you have a great day. Hopefully you enjoyed that video. Give me a thumbs up on that video. Subscribe to my channel, and I will see you next time for Lewis.Structure Rules.